All right, so we are going to say that the scale factor, also nicknamed K, which is also a coefficient, is a multiplier. Let's put a box around that word, multiplier, with these coordinate point variables x, just like it says here. So this word right here, dilate, just like your eyes do. And if you would go ahead and put a box around that we're gonna draw a little eye. You can put a little eyelash over here. Okay. Dilate means to enlarge or reduce. A couple other things. If the scale factor, let's go ahead and write a K here. If the scale factor is less than 1, then this guy's going to get smaller, and write smaller, really small. If the scale factor, write a K here, is greater than 1, then the shape is going to get bigger. It is as simple as that. Many times you'll be able to figure out what the answer to the question is just because you understand the concept of the scale factor, and if it's less than 1, it's getting smaller. If it's bigger than 1, it's getting bigger. Let's look at the example. We have 3 points on this triangle. We have J, K, and L. You have got to be able to find the address for J. Remember, you started 0, 0. It is 2, 1, 2, 3, 4. Now we need the address for K. It is 1, 1. And the address for L is 4, 0. In this particular problem, it's asking us, the scale factor K is going to be 2. Though every one of these has a rule, and the rule looks like this. The rule says you're going to take any point, X and Y, and then you're going to draw an arrow, which means to transform. We're going to transforming it using this rule, some number times X and some number times the Y value. In this case, our scale factor is going to be 2. So we are simply going to multiply all of the X and Y values by 2. We're going to double them. 2 times 2, 4. 2 times 4, 8. That's going to be your new point, J prime. So we can come over here and go to 1, 2, 3, 4. Up to 1, 2, 3, 4, 5, 6, 7, 8, and put a dot there. And we're going to label that J prime. That's the new location for J. Let's go to K. 1 times 2 is 2. 1 times 2 is 2. Our new location for K, K prime, is now at 2, 2. And we'll label that K prime. 2 times 4 is 8. 2 times 0 is 0. Our new location for L is going to be L prime. It is at 8, 0. Put a dot there and label it L prime. Now, we are simply going to connect these dots. And when you do, you're going to see that it creates a similar triangle. Not an identical triangle, it creates a similar triangle. What makes it similar? It's the exact same shape, it's just bigger. How much bigger?
2 times.
2 times bigger. The last thing I want you to see, you may not necessarily have a ruler with you, but that's okay, is it's getting bigger from 0, 0. So if you put your pencil on 0, 0 and you were to draw a line through J, you're going to go right through J prime. If you put your pencil on 0, 0, and you draw a line through K, you're going to go right through K prime. And if you put your pencil on 0, 0, and you draw a line through L, you're going to go right through L prime. And so another word for enlarge might be expand. Another way of saying it is if you're reducing it, if you're going the other way, 0, 0 would be the drain. And everything would shrink and just go disappear right into 0, 0. If you can imagine that. Let's look into the next one. We've got 4 points. We have to find the location for each point. M is at 1, 3. N is at 3, 2. O is at 2, negative 2. And P is negative 1, 0. This rule, because our scale factor is 3, it's going to look like this. X, y transforms, open parentheses, 3 times x and 3 times y. You simply take the coordinate points now, and we're going to triple them. 3 times 1 is 3. 3 times 3 is 9. My new point, my new location for M is M prime. It is at 3, 9. And we're going to label that M prime. My new location for N, which is M prime, 3 times 3 is 9. 3 times 2 is 6. 9. 1, 2, 3, 4, 5, 6. Just as a reminder, it has to be expanded right through N to land on N prime. That's what we're doing here. Okay? O. 3 times 2 is 6. 3 times negative 2 is negative 6. My new location for O prime is at 6, down 6. Right 6, down 6. That is O prime. And P, negative 1 times 3 is negative 3. And negative 3, or 3 times 0 is 0. The new location for P prime is at negative 3, 0. And we label it P prime. When we connect these dots, you should have an exact replica, not exact replica, you should have a replica that is just 3 times bigger. If you did this correctly, the lines on each of the 2 shapes will be parallel. So they'd be perfectly parallel. Okay. Once again, if you were to put your pencil on 0, 0, if you draw a line through M, you should go through M prime. Through N, you should go through N prime. Through O, you should go right through O prime. And the same with P. You're just expanding it out. Just like that.